So we can start. All right. So any doubt from the previous class? Any doubt if you are having? Please quickly respond. Otherwise, we will continue. No, sir. What about others, beta? Tanushri, Tharun, Varshant, Vijay Lakshmi. Please quickly respond. Do you have any doubt regarding previous class? Okay, guys. Okay, Abhiram. Okay, that's great. There is a saying that no study, no confusion. So is it the case that you are not studying or you are not revising the notes? Well, that's a very exceptional case that if you are studying and you are okay, Abhiram, that if you are studying and you are not having any doubt, it's very rare case. Revision is very important, beta. Revision is very important. If you have understood all the things in the class and if you are not revising, then that will not retain, because we are going to study almost 30-35 topics in chemistry. Okay, so at the end of 2 years, it will be a bit difficult to remember all the concepts. So I will suggest that after the class, try to revise at least once, right? That will surely help you. So okay, so shall we I think it is 11:15 and we can start our class. I have given some questions and some of you have responded on the Telegram, and I think each one of you have got the right answer, right? So you can see these are some questions which I have given you. Okay, you can match your answers. If there is any doubt, then please tell me, I will solve it. So in this case, if you see, hydrogen is attached with non-metal, boron is non-metal, right? Maybe some of you might not be able to identify which are metals and non-metals, but as we move, as we study the next topic, that is periodic table, right? Periodic properties, then slowly we will be able to understand which elements are a metal and which are not metals. So boron is clearly non-metal, then hydrogen will have +1. So if you see in this case, boron will have +3. Oh, sorry, -3, right? In case of H2O2, I am asking for oxygen. So you can use your brain that hydrogen will always have +1 if it is attached with non-metal. So in this case, it will have -1. I am calculating per atom. Per atom of oxygen will be carrying -1 fictitious charge, because this is not an example of ionic compound. This is an example of covalent compound. That is why I am just saying that it will have -1 charge, right? Is that okay, beta? Is that okay? Fine. So in case of Na2S, again, Na belongs to alkali metals, and all the alkali metals are going to have +1 charge. So if you calculate by using the simple method, then you will find that charge on sulfur will be -2. Similarly, all the alkaline earth metal, Mg belongs to alkaline earth metal. So all the alkaline earth metal will be having +2 charge. Okay. So if you solve this, you know the charge of Mg, then it will be -3. Here also I know the charge of fluorine, that is -1. Okay, I asked you to remember the rules in the given order. Okay, they are not going to ask you the direct rules. They are going to ask the rules. You need to apply these rules when problems are given like this. Okay, so fluorine is -1, so it will have +2. SRO2, again if you see, SR belongs to alkaline earth metal. Okay, so SR will be having +2. So if you see, then it will have -1. Potassium has +1. That is why oxygen will have -1/2. Okay, now these are some good example. I have given some good examples. In the case, if you see, we know information, certain information. See, always try to solve this kind of question in which you are having some certain or fixed information, or in which you are very sure that yes, in this case I cannot be wrong. So we know that fluorine always carry -1. So if you solve using this, then it will have +1. And on the similar ways, if you solve this, +2. Now here if you see in the last example, KO3, then potassium has +1. That is also very certain. See, I just want to tell you one thing, that in our case, metals are not going to have negative oxidation state. Metals are not going to have negative oxidation state. But in real life, in higher standards, we will find many example in those cases metals will be having negative oxidation state. Okay, but if nothing is mentioned, we are not going to solve. No, we are not going to fix the oxidation number negative. Okay, so if you see K is generally it belongs to alkali metal, so it will be having +1. That is why it will have -1/3. Now please tell me if any one of you have any doubt. Please quickly respond, beta. Anyone else, beta? If you are having any doubt, please quickly respond, beta. Ramesh, I am seeing your name first time, beta. Sudha also Sudha, please, beta. Sudha, can you listen me, beta? Tarun, Aviram, any doubt? Ramesh, please, beta, quickly respond. No doubt. Okay, okay, guys. Fine. That's great. Fine. So till now we have discussed only 3 rules. If uh, just check, we have discussed that fluorine will have -1 for sure. That was our first rule. Second, we have seen that alkali metals, they will have +1. Examples of alkali metals were sodium, potassium, rubidium, cesium. Right? Sodium, potassium, rubidium, cesium. Then alkaline earth metals. They will be having +2. And we are solving this, or we are giving these rules for combined state. And third one was related to hydrogen, that if hydrogen is attached to metal, then hydrogen will be having -1. If it is attached to non-metal, beta, then it will be having +1. These are our rules which we have studied till now. So now I am writing the next one. We have already studied. These are some rules for which we are very sure. Okay, so if there is any fluorine, then use for fluorine first. Okay, without any exception, you will find -1 in combined state. Same for alkali metals, +1 in combined state, +2 for alkaline earth metal. Hydrogen for metals -1, non-metals it will be +1. So these are some rules which we need to use first. Then oxygen. Let's figure out for oxygen. Whenever oxygen is present at oxide, if there is given in the question, it is the oxide of something. Okay. So in oxides, oxygen will be present as beta -2. Generally, if nothing is given, we are going to consider it as oxide and it is going to have -2 oxidation state. But there are some exceptions. If you do not know these exceptions, then also you can solve them, because we have already given some problem related to exceptions in the homework. So first one is that there are certain, first thing is oxides. For example, N2O3, N2O5, P2O3, P2O5. In this case, if we want to figure out the oxidation number of other element, for say nitrogen, in this also nitrogen, in this phosphorus, in this also phosphorus, then you can easily solve by considering oxidation number of oxygen as -2. So it will be nothing but +3. In this case, it will be +5. In this case, again +3, +5. Okay. If oxides are given, then without thinking, you can directly use oxidation number of oxygen as -2. But if there are certain compounds which forms peroxides, in peroxides, whenever there is any compound which is peroxide, then it will be having such kind of bond. It will be having such kind of bond in which two oxygens will be linked with the single bond. So this linkage is known as peroxide linkage. This is known as peroxide linkage. If there is peroxide bond or peroxide linkage in any compound, then the oxidation number of oxygen becomes -1. We have already done some good examples like H2O2. We have already done H2O2, Na2O2, right? SR2, SRO2, BaO2. These are all the examples. You will not find any other peroxide which is stable. These are something peroxide which are very stable or relatively stable. In this case, if you see, this is -1. This will always be -1. This will also be -1. This is also. So what do you call? This is hydrogen peroxide. If you want to name it, its name will be hydrogen peroxide. So name itself tells, right? If you want to, this will be barium peroxide. Its name itself is barium peroxide. But any doubt? Any doubt till now? Tanushree, Vinay, Siddharth. Clear. What about Tanushree, Siddharth? Siddharth, beta, you are having very nice DP. So please show some activeness. Yeah, great. Okay, good, beta. Good. So these are some good examples, right? You can also remember these. Okay. Generally, I told you can use some NEHA. This is NEHA for sodium and hydrogen, and then you just reverse it, so it will become BiPasa, right? So this is how you can remember them. NEHA, BiPasa, right? BiPasa for barium, Sa for strontium. So you can remember them. These are some peroxides which are stable. You will find peroxides, and another group is coming, that is superoxide. In superoxides, in this case, oxygen will be having such kind of linkage. Okay, then oxidation number of oxygen becomes -half. I am giving, these are only examples. KO2, rubidium O2, cesium O2. These are some stable peroxides. So these are three examples only, right? So here it will find -1/2, -1/2, again -1/2. So these are only three superoxides which are stable in nature. So 4 oxides, 4 peroxides, and 3 superoxides. Right. So you do not need to remember the oxidation number for these compounds, because you know that potassium must be having +1, rubidium must be having +1, cesium must be having +1. That is why oxygen should have -half, -half, -half. Is that okay, beta? So these are two exceptions for peroxide and superoxide, and peroxide and superoxides are stable only for S block element. Right. I am writing just note for inorganic chemistry. So similarly, if there is any concept related to for future chapters or in for inorganic chemistry, then I will be introducing it also. So peroxides and superoxides are stable for alkali metals and alkaline earth metals So these are two. Now there can be oxygen will be having positive oxidation number if it is linked with fluorine. We have already done these two examples, O2F2 and other is OF2, oxygen difluoride, oxygen fluoride. So in this case it will be having +1 and it will be having +2. These are some good examples, right? Any doubt, beta? You can see on the screen, and if you are having any doubt, tell me. I will be giving you one more exception. Please respond. Any doubt? See, in this topic, I can guarantee you that you will not get any question beyond our notes. You will be able to solve all the questions. I will try. I will ensure that all the examples, all the good examples, and all the concepts related to oxidation number are covered. Just need to revise the notes. Any doubt, beta? Okay, fine. So there is another exception, that is fourth one, that is related to ozonides. Oxygen in ozonides. We have already understood one example, that is KO3. So in this case, if you see, you know that potassium is always having +1, so it will have -1/3. These are some exceptions for oxygen. Otherwise, in all other compounds, if you see any other compound which we have not written over here, always try to understand that oxygen will be present in -2. If the compound is not peroxide, superoxide, or ozonide, or with fluorine, then it will be for sure it will be having -2. There will be another hint. Note, there will be many compounds in which, if you see, oxidation number will be coming more than its maximum oxidation number. So I'm just writing a rule, and we will be using it. If in given compound, oxidation number of metal, oxidation number of asked element is greater than its oxidation number maximum, or is greater than its possible oxidation number, possible maximum oxidation number, then that compound, then oxygen present in that compound must be having peroxide linkages or superoxide linkages. See, I will tell you what is maximum oxidation number, possible maximum oxidation number, just in a while. But as we were discussing about oxygen, so I have told you, if any compound oxidation number of asked element, for example, sulfur is having +6. I am just telling you that oxidation number of sulfur is +6. But if we solve by traditional method and it comes +7, +8, or +10, then it is for sure that it will be having peroxide linkages. Okay, so I'm just giving you hints. I'm just preparing you. Okay, so next, as we have discussed oxygen, now just a second. Fourth, so let us write A, B, C. This is D. Now fifth one, that is halides. Halides or halogens. Halogens. We have already discussed about fluorine. So now chlorine, bromine, and iodine. These are iodine. Chlorine, bromine, and iodine. So, if they are presented halides, in halides, if there is a compound, it is known as chloride, bromide. Halides means chloride, bromide, or iodide. If in the name it comes chloride, bromide, iodide, then chloride will have in -1. That is chlorine -1. It is having ion chlorine -1, bromine -1, I -1. So in halide, oxidation number of halogen, that is X. Let's say X will be nothing but -1. That is fixed, beta. If compound is halide, if it is something else, then we cannot say. But if it is halide, then generally it will be having -1. Sixth, beta, sulfur. Sulfur. Okay. So in sulfides, if there is any compound known as sulfide, right, then it will be having, in sulfide, sulfur will be present in -2. For example, H2S, Na2S, right, HGS, right. So if you see in all these compounds, -2. Very simple. Similarly for halogen also you can write, right. So sulfur हो गया और halogen हो गया. Oxygen I have already told you. Then let's study about maximum and minimum oxidation number. Seventh, maximum and minimum oxidation number. Possible maximum and minimum oxidation number. Possible minimum and maximum oxidation number. So did you get the notes of the previous class? Did you get the notes of the previous class, beta? Please respond, beta. Did you get the notes of previous class? Yes. Okay, fine. Fine, beta, fine. See, if you see there is periodic table. Periodic table you must have seen. Yeah, okay, Siddharth. Okay. So in periodic table you can see that we have divided the elements in some blocks. Okay. The leftmost is S block, then rightmost is P block, and in the middle it is D block, and there is 2 rows in the bottom, that is F block. So in the leftmost S, P, here D, and in the lower that is F. This is how we have segregated. But if we see for D, it is very variable oxidation state. This is characteristic of D, that they do not show fixed. They can have more than one oxidation state, more than one oxidation numbers, and their oxidation number changes frequently. Similar for a fluorine, F block. Okay, so similar for these two blocks. So we are not going to write maximum and minimum for these elements. We will try to understand the maximum and minimum for S and P. That's it. But we will be focusing first on P, because for S we have already understood that +1 is the for alkaline metals and +2 for alkaline earth metal. So we are remaining with the P block. So we will try to discuss for the P block, just for P block element. So if you see, there is first carbon family. There is first carbon family. I am just writing all the names: carbon, silicon, germanium, tin, and lead. Right. Then there is boron family. Sorry. First there is boron family, then there is carbon family. Boron family, if you see 13th group, right? Boron, aluminium, gallium, indium, and thallium. Then there will be nitrogen family, beta. Nitrogen family. Nitrogen, phosphorus, arsenic, antimony, bismuth. These are some elements. Then oxygen family, beta. Oxygen family. Oxygen, sulfur, selenium, tellurium, polonium. These are some. Then there will be halogen family. If you see, for halogen, we have already discussed for fluorine. Fluorine will always be having -1 in combined state. So I am not writing fluorine, only chlorine, bromine, and iodine. Similarly, we have discussed for oxygen. So I am also removing the oxygen. We have discussed fluorine in detail. So we are just trying to figure out the maximum and minimum for these metals, these elements: boron, carbon family, nitrogen family, oxygen family, and halogen family. So minimum is nothing but, do you understand better what is valence shell electron? Do you understand what are valence shell electrons? Do you understand what are valence shell electrons? Valence electrons are better nothing. They are just the electrons present in the outermost shell. Okay. So valence shell, if you see, I am just drawing valence shell for each. So in this case, valence shell electrons, they are present only 3 valence shell. Okay. Valence shell. I am just writing the valence shell. I am drawing the valence shell, only valence shell. So it has only 3 electrons. Right. Similarly for carbon, I am drawing for carbon also, for nitrogen also, for oxygen, and similarly for halogen. So I'm just drawing the valence shell. Okay. And they are having 4 electrons, beta. They are having 5 electrons in the valence shell. And they are having 6 electrons. And they are having, all of them are having 7 electrons in their outermost shell. So they are having 7 electrons. They are having 6 electrons. They are having 5 electrons, beta. They are having 4 electrons. In the outermost shell, they are having these electrons. So if you want to figure out the minimum oxidation number, if you want to figure out the minimum oxidation number, and here it is maximum oxidation number. So minimum is nothing but valence shell electron or outermost shell electron. Valence shell electron, I am just writing the formula. Valence shell electron -8. Right. This is the formula. So if you find for halogen, it will be 7 minus 8, that is -1. So it is its minus, it's its minimum. If you find any halogen, it cannot have -2, -3, -4. Okay, if there is any example in which it is coming as -2, that is also wrong. -3 is also wrong. For oxygen family, it will be having 6 - 8, that is -2. So if there is any example in which it is coming in -3, -4, that is also wrong. For nitrogen, 5 - 8, that is -3. So in any example, if oxidation number is coming -4, -5, then that is wrong, very wrong, right? So carbon family can have 4 - 8, that is -4. But rarely you will see this. Rarely you will see this, right? Rarely. In their hydrides, you will find this in their hydrides. Boron family, you do not find like this. You will not find any example 3 - 8, -5. You will not find this, right? Maximum oxidation number. Maximum oxidation number is nothing but valence shell electron. It is nothing but valence shell electrons. So for boron family, it will be nothing but +3. It will be +4. It will be +5. It will be +6, +7. Is it okay, beta? Is it okay, beta? If you find any compound of boron family which is having more than +3, that is +4, +5. No, that is not possible. +4, +5 is not possible. +5, +6 is not possible for this case. Similarly, for nitrogen, +6, +7 is not possible. Here also +7 is not possible. Here also +8 is not possible. Is that okay? Is that okay, Siddharth? Is that okay with everyone? You cannot find maximum oxidation number or oxidation number of boron family more than +3. You cannot find even a single compound in which boron or aluminum or gallium is having oxidation number greater than +3, right? Is that okay? Is that okay? Is that okay? Yes, I will give you examples. I will give you some examples, then you will understand it. Okay. Now I am giving you some very good things, good examples and good questions. But till now we are having only 3 compounds. There are only 3 compounds. There are only 3 compounds in which oxidation number of element is +8. So if you found any other example apart from these 3, then we are doing wrong calculation or we are taking oxygen in -2 wrongly. Okay, so these 3 examples are ruthenium oxide, ruthenium tetraoxide, osmium tetraoxide, and pergenic acid. These are 4 examples. I am writing them: ruthenium tetraoxides, osmium tetraoxides, pergenic acid. Okay, in this case, ruthenium is in +8 state. This is also +8. Here, xenon is also in +6. Just a second. +8 state. Is that okay, beta? You can see. You can see. Any doubt? So if you found any other element, if you find any other compound in which central atom or the underlined element or atom is coming with the oxidation number 8 or greater than 8, then we are doing some wrong calculation. Okay. These are only 3 elements which we need to remember. Shall I move ahead? Is it okay, beta? Please quickly respond. Yes, okay. So I am giving you some examples. Please solve for them. Calculate oxidation number question. Calculate oxidation number of underlined element. Solve these 15 beta quickly. I'm waiting for your response. Solve these quickly, and then I will give you the answer. Then we will do some good questions. Let's solve these. Two minutes more, then I will write the answers. Very easy, beta. Okay. So if you see, you just tell me which one, in which case you are facing difficulty. You must be knowing the electronegativity, beta. Yes, I have told you in the previous class. FON, phone, kal, bura, aya, sulfur, carbon, and hydrogen. Phone, kal, bura, aya, sunkar, hadkaya. So this is which I want you to remember. This is phone. So this is the most electronegative, second most, and third most. Then chlorine, then bromine, then iodine, then sulfur, then chlorine, then carbon, then hydrogen. This is your electronegativity order. Electronegativity order. So you can use that. Okay, okay, beta, time is over. So now I am just telling you, if you solve for this thing, KMNO4, it can be solved. You know that for potassium it is +1, right? It is +1 for potassium. We do not know for manganese X. We know generally if nothing is given, we will consider oxygen in -2, that is 0. And if you solve it, then X will come as +7. Right? I hope every one of you have solved it correctly. Similarly, for potassium, and this the second example, potassium, this is potassium permanganate. So you also expected to know the name of this compound, potassium permanganate. This is potassium dichromate. These are two very good reagent. Potassium dichromate. So if you solve, potassium is having +1, chromium we do not know, oxygen again -2. If you solve it, then it will come as +6. Now, in this case, if you want to solve CrO2 Cl2, right? So if you solve, it will come as +6, right? CrOCl2. This is very good example which I will solve you later. Okay, so you can keep this in mind. Not CrOCl2, it is okay. Okay, CrOCl2 will be having, yes, fine. It will be having +4, simple one. HCN, some of you might be facing problem in HCN. So HCN is nothing but it is like this, right? Nitrogen is more electronegative than carbon. Okay, you can also solve like this. If you break these bonds, then all three electronegative atom will be having -3 because 3 bonds are broken. Here in this case, hydrogen will be having -1, sorry, +1 because it is attached to metal. It is attached to non-metal. So the charge on carbon will be +2. Or you can solve +1, carbon ka X, nitrogen -3, then 0. If you solve, then also it will come as +2. But tell me if you are having any doubt in this case. This is an acid, hydrocyanic acid. This is a hydrocyanic acid. It works as acid. Is this okay, beta? Any doubt? Niharika, Siddharth, Tanushri, Tharun, Vinay, Aviram, please tell me. Or I will repeat it. I will explain it once again. Quickly, beta. No doubt. Understood. Okay, fine. N2O5 is again very simple. It will have +5. RbO2, we have already done it. We have already done it. In this case, Rb will be having, it will always be having +1. Just to confuse, I have given this. Rubidium belongs to alkali metal. It will always be having +1. And in this case, oxygen will be having -half. It is fixed, beta. For rubidium, it is fixed. We already know that it belongs to alkali metal, so it will be having +1. Similarly, in this case, it will be having +2, and oxygen will be having -1. If we see sulfur, it will be having +6. You can solve it. +1 into 2, sulfur is X, oxygen 4 into -2. So if you solve it, 0, it will come as +6. Nitrogen, it will be having +5. It is again +5. If you solve this, it will be having +3. Here it will be having +1, +7, +4. Any doubt? You want me to explain any of the example out of given 15? Please tell me. Okay, beta? Is it okay? So I think you guys are writing everything. You guys are trying to write. Yes, okay. So after the class, I will provide you notes. Just try to understand the concept, right? Okay. Now just try to remember these anions and some cations. These are some complex anions which you need to, I want you to remember these because these are very important ones. You will see them frequently. First one is sulfate, beta. First one is sulfate, SO4 -2. So you must be knowing this sulfate is having, it carries -2. Then this is sulfite. It also carries -2, sulfite. Then this is nitrate, beta. I will tell you how do we name this, but later. Right now we do not have enough knowledge. Then this is NO2-, that is nitrite. I want you to remember this. If in any anion you add H, then that will be termed as bisulfate, bisulfite, binitrate. So if you write HSO4-, then it will be known as bisulfate. If it is HSO3-, then it will be known as bisulfite. If HNO3 doesn't make any sense, right? Similarly, you can write carbonate ion. So I am writing these below. Yeah. Then I am writing carbonate ion. This is carbonate. Carbonate. So it will be, if you write HCO3-, then it will be bicarbonate. So if you find any compound which is having such anions, you must remember them. Then there are also, this is phosphate ion, beta. FOPO-3. This is phosphate ion. Right? These are some important ions which you will encounter. So I'm just telling you the names. Phosphate ho gaya. Then CN-, if there is some CN-, then it will be cyanide ion. This is cyanide ion. Right. Another very important N3-, because if I would not tell you, then you will always mistake this. This is N3-, this is azide ion. I have already told you in initial class. This is azide ion. Okay. So let me give some examples. And there is cation. These are all anions. There might be many, but I have just told you some important. Then if there is given NH4+, then it will be ammonium ion. This is ammonium ion. Okay. You do not try to remember all this in one day. Just look at these examples twice, thrice, 5 times, right? Then slowly and gradually you will remember all these. Okay. Do not try to memorize all of them. You will find many compounds in coming 12 or 15 months. So slowly and gradually you will remember them. Just look at the table and try to just read them. This is sulfate, this is sulfite. In sulfite there are only 3 oxygen. This is carbonate. So in ammonium ion, NH4+, right? So some more examples I want you to give. Find for NH4NO3 in this case. Then very good example. If you do not know, then you will not able to solve this question, the last one which I have given. So see, if you already know that ammonium is one of the example of complex ion, and it carries +1. So you can write +1. Nitrogen X, 3 into -2 for oxygen, total 0. So it will have +5. Otherwise, you have to solve for ammonium and differently. This is barium azide. This is barium azide. And if you do not know the nitrogen, then you will be having problem. But if you know barium belongs to alkaline earth metal, it must be having +2, right? So there also from there also you can solve it, that for nitrogen, barium is having +2, and nitrogen, there are 2 into 3 and X equal to 0. So we solve this, then each nitrogen will be having -1/3. -1/3. And in this case, if you want to solve, it will come as +3. Very, very trivial example. So as you know, sulfate is having -2. So for any binary salt, a binary compound or salt, example AXBY, what we do, how do we break it? We have already know that if there are two things, we try to use crisscross method. So in this case, what we will do, we will put X number of A ions having +Y charge and Y number of B ions having -X charge. This is what we do. We try to put this charge here and this. This is, for example, we want to write Mg nitrite. Okay. So nitride, whenever there is written nitride, it is having -3 charge. So -3 Mg is having +2. So you need to do this thing, crisscross method. So for any binary salt, you are able to solve this, right? Is it okay, beta, till now? Is it okay? I will be giving some good examples. Just wait. We are going. I am moving to the peak. We will be having some very nice examples. Okay. Also, I would like to give you another information. As I have already told you that for D block elements, they are having variable valency. But for maximum, chromium has maximum +6 and manganese has maximum +7, because compounds of these two elements are very important. Maximum oxidation number for chromium is +6, for manganese is it's +7. So if you allow, then we can solve some good questions. Shall I move ahead? Tell me, shall I move ahead, beta? Yes, fine. Saiji, okay. Beta, till now we do not know how to draw structures. But once we have studied chemical bonding, then we will be having some knowledge that how to draw structures. Okay. So to figure out the oxidation number of some compounds, we need to know the structures, right? But we will be doing some good examples. For example, H2SO5, H2S2O8, CrO5. These are some good examples. Then another one, very nice example, K3CrO8. Very good question. You will not find this question anywhere. Very rare, even not in books. Please give me the oxidation number of underlined. Please, I want your answer, response in the chat box. Please give me. I'm waiting. These are very good example, and you will see these questions in exams frequently. Come on, I am waiting for your response, beta. Come on. Come on, Niharika, Tanusri, Tarun, Vinay, Janvi, Aviram. Yeah, that is clear. I understood. But please give me the answers, Tanu. Are you even listening me? Give me the oxidation number of sulfur in H2SO5. Give me the oxidation number of sulfur in H2S2O8, in CrO5, in K3CrO8. What happened? If you use the traditional formula like +1 into 2 plus x and 5 into -2 is equal to 0, then you will find x will come as +8. And I have told you only there are three examples. We have told you only there are 3 examples which are having +8 oxidation number. Then surely this is wrong. Also, as we know, maximum oxidation number of sulfur is nothing but +6. So how it is not possible to have +8 oxidation number for sulfur, right? So there we are doing some mistake. If we solve for this, in this case it will come as +7. In this case x will come as +10, and we know that oxidation number of chromium is cannot be more than +6. This is also wrong. In this case if we solve, it will come as +13. Again it is not possible, beta. It is +6, right? So there is some mistake, and I have given you one note. If you remember what I have told you, for oxygen, if there is any compound in which oxidation number, जिसकी oxidation number पूछी गई है, if in given compound oxidation number of asked element is greater than possible oxidation number, then oxygen may be present in peroxide linkages, right? Let me give you one formula. Number of peroxide linkages, beta. Number of peroxide linkages. However, it is not very important for you. Number of atoms जिसका ऑक्सीडेशन नंबर पूछा गया है, for which oxidation number has been asked, okay, into oxidation number minus maximum oxidation number divided by 2. So let me solve for first one. Let me solve. These are very good example, and you can find out these three, at least these three, directly in question, okay, in previous year question. If you see the questions of NEET, each year or the alternative year, you will find these three examples. So H2SO5, if you see, you can write the example. There are sulfur, only one sulfur atom, okay. You need to write only underlined atom. It is only one, so it is 1 into oxidation number is coming as 8, maximum can be 6 divided by 2, so it is having 1 peroxy linkage. I have already told you what is peroxy linkage. For H2S2O8 you want to solve, you can solve. There are 2 atoms, oxidation number is coming 7 minus 6 divided by 2, so it is again coming as 1. For CrO5 also you can solve. There is only 1 atom, oxidation coming as -10, maximum can be 6 by 2, so it is coming as 2. We are not solving for this because in this case if you solve, it will be coming as fractional. So I will tell you this directly, right? So let us draw the structure of H2SO5. It is nothing but there are only one peroxy linkage. So this is peroxy linkage. There are three oxygen which are simply in oxide form, but there is one peroxy linkage. This is, you can see peroxy linkage, right? For this example, peroxy linkage, one peroxy linkage, but it is present between sulfur and sulfur, and then distribute atoms symmetrically. CrO5, very nice structure. It looks like butterfly. So these are the structures, but I am just giving you one hint that if oxidation number of any element is coming, then it's maximum. So generally it will be, the answer will be maximum oxidation number. For example, in this case, it's coming 8, which is greater than 6. If you solve this, then oxidation number, if you solve this, how will you solve this? There are 3 oxygens which are present in -2. There are 2 oxygen which are present in -1 because they are peroxide. Hydrogen connected to metal, that is +1. Sulfur X. If you solve this, then it will come as +6. Here it is also coming as +6. It will also come as +6. So if there is any element which is in the question, it is coming the more than maximum, then your answer will be maximum. Okay, in this case, if you also try to calculate for chromium, let's say X, there is one oxygen which is present in -2. There are 4 oxygen which are present in -1 equal to 0. Then if you try to figure out, then it will come as 6. So I'm just writing the name. This is known as beta carrose acid. Very important, carrose acid or peroxy monosulfuric acid. Monosulfuric acid. This is known as Marshall's acid. You just see the names. You do not need to remember beta. Just try to know that there is something Marshall's acid. Okay. So its name is nothing but peroxy disulfuric acid. Disulfuric acid. And it is nothing but this is chromium penta. We try to know it, chromium penta, but I have already told you that it is having butterfly structure. So it will be having butterfly structure. Butterfly structure. Now we are left with only this example. So I am just giving you the structure of this. A bit complicated. You will say, sir, how, if some new question comes, how we will draw the structure? But these are some good questions. You will not find, you will rarely find some different structures than these. Okay. Other compounds will be of, you can solve by traditional method. You just try to remember these questions, right? Marshall's acid, carrose acid, butterfly structure, CrO5, right? This thing. So if you solve this, in this case, it will come as beta +5. If you try to solve this, it will come as +5. Chromium. Okay, these are some good examples. These are some good examples. Okay, so try to revise all these questions. And if you have any doubt, then tell me. I am giving you some questions. Please try to figure out the oxidation number of underlined element. Homework I am giving you. Underlined elements. Fe3O4, Fe second, Pb3O4 third, Br3O8 fourth, Fe 0.930, right? Fifth. PbCl4 sixth. Yes, barium O6, right? Seventh. Na2S2O3 eighth. H2S4O6. Ninth, you can write this. Ninth, Na2S4O6. 10th, CrOCl2. Sorry, CaOCl2. This is very good example. CaOCl2. So in this case, you need to find out chlorine, sulfur, lead, iron, xenon, sulfur, and again sulfur. You write these, and in the next class we will meet. Okay, and I will share this handout right now. You write these, at least these example. Please tell me, how was the class? Please tell me, how was the class? Yeah, okay. I know it I expect that in this case, in today's class, you might be having some problem. It is because you have not studied few concepts, right? But slowly just revise the examples given to you and try to solve the homework given to you. Okay, you will be perfect. In the next class, you will be perfect in this concept, right? Then we will understand what are oxidizing agent, reducing agent, what are different type of reactions: oxidation reaction, reduction reaction, redox reaction, disproportionation reaction. Okay, okay beta, have you written it? Have you written it? You can take the screenshot beta. Yes, fine, fine. Tanu, have you written it? Janvi, Vinay. Yes, okay beta, fine, great, great, great. So we will meet on Monday. Yes, okay, fine, we will meet on Monday. Okay, great. So I am finishing the class. I am